We'll start looking at the practice test. Hopefully you remember more of it than maybe you think you will. Make it easier. Get prepared for it. I try not to go too heavy on any of the particular sections in case there was one that gave you more trouble than the others, and maybe there's just a couple questions on there. Everybody have a good break? Okay. So, and then I posted in the announcements on Canvas, you may not have seen it yet, but our final on this class is on Monday, a week from today. I think this class is at either at 10 or 10:30, I think. I think it's 10:30. And we'll just be in this same room. All right. Number one, we're finding numbers in a sequence, and these numbers are a little bit, they get big. You may see a pattern there. What do you think's going on? Yeah, I'm sorry. Yeah, the final is optional. Yeah. No, you're not going to pass. Yeah, if you're happy with your grade, you're finished. Yeah. Yeah, okay. I couldn't remember what you made, so I didn't know. Yeah. If anybody's, so that was in the announcement too. If you're happy with your grade, you don't have to worry about the final. Okay. I should have let off with that, shouldn't I? Just in case. Yeah. See you later.
Appreciate it.
Mm-hmm. Yeah, me too. All right, so looks like to me to get from 13 to 26, we're multiplying by 2. And again, those numbers are a little bit big, but you could check it, right? You could divide. And then 26 to 52, that's multiplying by 2. So it looks like we need to multiply by 2 to get to the next term. So the next one would be 208, and then the 208 times 2 would be 416. Okay. So we're at times 2. Okay, so then this is the part that's maybe a little harder to remember. Would that make it a arithmetic, geometric, or neither one of those? So arithmetic's if you add or subtract the same number over and over. Geometric is this one where if you multiply or divide by the same number. So this one's geometric. Yep. Okay. Number 2. Probably the big thing on this is just remembering what the symbols mean. It says find A, and then we got that U symbol B. You may remember what the U is. We had 2. We had intersection and we had union. Yeah, and that's, so this one, this one's the union, right? The one that looks like a U is union. And then the rule for union, like you said, is we want everything, right? We want anything that's in A or in B will be in the union. So A union B. And so we got 1, 2, 3, 4, 5, 6, 7, 8. There's no 9. 10, 12, and 14. So everything that's in both of the sets, and you don't have to write anything twice. Union. Bless you. Okay. So the other one on number 3 is the symbol is upside down. That one's the one that's the intersection, is what we call that. So anybody remember the rule on that one? Yeah, it's just the ones that are in both sets. That's right. So let's see, 3's not in both, 8's the smallest one in both, so 3, 5, 7 are not. 9's not, 11's not, 13's not in both. So on this one, we don't have anything in the intersection. So this brings up one other thing. You remember what we write for a set that doesn't have anything in it? Yeah, the circle with the line through it, the empty set. Nonsense, or a little bit of set theory. Or got some survey analysis. So we got Venn diagrams. Says we had a survey of 800 school employees that yielded the following information: 599 were instructors, 430 were full-time faculty, and 345 of the instructors were full-time faculty. So let's draw it out. Let's see. I have instructors here. Full-time there. And it said 345 were both. Full of the instructors were full-time faculty. So well, let me draw my circle a little better. I have 345 in the middle. And then to figure out how many are left in each one, we can use our other numbers. So it said 599 were instructors. So we know the instructor circle's got a total 599, but we got to subtract the 345 that are already in there. So outside, where they do not overlap, that leaves us with 254. And it says 430 were full-time faculty, so the full-time faculty circle's got a total of that minus the 345. That leaves us 85 out here. And then it says how many of the surveyed school employees were instructors or were full-time faculty. So here, that one's a little confusing, but that's the inclusive or. So really we want the total of all three of these. We want the ones that were instructors or full-time faculty or both. Okay. So we got the ones that were just instructors, the ones that were both, and the ones that were just full-time. We'll get our total here. Gives us 684. You could do that one with the inclusion-exclusion principle too. You could take the instructors plus the full-time faculty minus the ones that were both and get the same thing that way. Questions on that one? If you have a question, make sure you ask. That's what today's for. Anything? Okay. Number 5 says which one of the following is not an example of a mathematical statement. So a mathematical statement has to be either true or false, not both. Things that are not mathematical statements are like opinions or paradoxes. So A says my boyfriend was born in Atlanta, so that would either be true or false. B says nobody drives on Highway 16, there's too much traffic. What do you think about that one? That's the one that's not a mathematical statement. Why? Yeah, too much. That's just an opinion, so makes it not a mathematical statement. And if we look at the other choices, C says Derek Jeter's jersey number was 2. That's either true or false. And then D says this milk has no chocolate in it. So that's either true or false. Number 6. No. Number 6 says if 32 of the 92 people who swim at the YMCA are adults, what is the ratio of adults to children who swim at the YMCA? So if 32 of the people are adults, we need to figure out how many of the 92 people are children. So we got 92 total people minus the 32 adults. Means we must have 60 children. So then the ratio of adults to children, we had 32 adults. Let me write it like this, 32 adults, 60 children. And it wants it in lowest terms, so let's see, that's 16 over 30 or 8 over 15 in lowest terms. So either you could write it as 8 to 15 that way, or you could write 8 to 15. So we want adults to come first and then children to come second. Is it on that one? Good. Okay. 7 says Mary went shopping and spent $33 on sweaters. If she spent $54 total, what percentage did she spend on sweaters? So she spent 33 out of 54 total dollars on sweaters. So we just need to change that to a percentage. So 33 divided by 54 gives us the decimal version. And then either you can think about moving the decimal place 2 times to the right or multiplying by 100 to get a percentage. And it says round your answer to the nearest percent, so call that 61%. Don't know. Okay. Number 8, we need a formula for, so this would be something that would be on the formula sheet. It says find the sum of the measures of the interior angles of a 22-gon, so a 22-sided polygon. So we would have a formula for the sum of the interior angles. So n here will be 22. We'd have 22 minus 2 times 180. It's 20 times 180. So what is that, 3,600 degrees? Yep. Let's just plug it into the formula. Okay. Seems like pretty much that one went pretty well on the last time we tested on that. So. Okay. And another formula we'd have to have on the formula sheet. It says find the volume of the figure. So this one would be a cylinder. So our volume formula would be pi r squared h. So here it gives us the radius of 4. The height is 6. And it says use 3.14 for pi, so 3.14 times 4 squared times 6. So let's see. That is 301.44. And we were in feet. And since it's volume, it's cubic feet. I think those went pretty well too on that test. Okay. Number 10, maybe this one's a little easier than the one on test 3. Okay. To decide which study uses a population parameter. So if it says anything about a sample, you know that one's out. Okay? Because if we're talking about a sample, it'd be a sample statistic. And so A is in a study of 89 of the children diagnosed with cancer at Leland Memorial Hospital, 70 children were cancer-free. So it's not saying 89 is all the children that have cancer there. Okay? So it's not A. B says Parkland Hospital performs 15,000 births a year. Of 1,000 subjects in the study on multiple births, 38 gave birth to twins. So we just have 1,000 in our sample, and that's what that's telling us about. So it's not telling us about all 15,000. So we're out. C says the National Institute of Pediatric Dentistry reports that 42% of children ages 2 to 11 have had at least one cavity. Hey, that one's looking good so far. Let's check D. D says 1,000 of the 1,883 participants in last year's Ironman in Kona, Hawaii were interviewed. So here we're just interviewing 1,000 of the people. We're not talking about all of them. So that one's out. So our population parameters. Those other ones would be sample statistics. On that one, any maybe? Hmm. 11 says find the median. We got to remember which one is the median. Median is the middle number. To find that, we got to put our data in order. And I'll help out and I'll have them in order so you don't have to waste time doing that. Let's see, so I see 18, 19, next 23 next, 20, 25's twice, 26, 27, 30, 31, 32, 36, 38. Okay. So then we're counting off numbers from both sides, looking for our middle number. This one we have 2 numbers in the middle. How do you remember how to get the median if we have 2 middle numbers? Add them together and divide by 2. That's right. So 26 plus 27. Divide that by 2. It was 26.5. If we only have one number in the middle, that number is the median. If we have the 2 middle numbers, we add together, divide by 2. Mm-hmm. 12, we do have a little bit of the financial math on here. Again, I'll give you the formulas on these. 12 says determine the simple interest, so that's I equals PRT. So we got $10,000 after 30 years if the APR is 5%. So our starting amount, our principal is $10,000. Our interest rate, 5%. We got to change that to a decimal, so 0.05. Got to move the decimal place twice. And then 30 years, so times 30. And this formula just gives us the interest, so we don't have to subtract or anything. And so we'll get $15,000. 13's a little uglier. But a lot of people did good on this one. Is we've got a credit card, has a balance of $9,210 at an APR of 9.49%. We're going to pay $400 each month. How many months will it take to pay off the balance? This is the one with the logarithms in it. It's 1 minus R over N times A over PMT. I think that's plus on the bottom. Let me double check real quick. I didn't bring a formula sheet with me. I want to make sure I'm telling you correctly. One moment. Yeah, that's right. Okay. So have negative log 1 minus, when we change our APR to a decimal, that one's 0.0949. Move the decimal place 2 places to the left. Over here, it's how many times a year we're making payments, so we're making monthly payments, so N will be 12. And then we got a balance of $9,210. It's the amount we owe, divided by the payment we're making, 400, over the log of 1 plus 0.0949 over 12. So if you want to do top and then the bottom, you just have to be careful to leave a bunch of decimal places. You can put it in all at once. You can, yeah. Yeah, so usually on mine, what I want to do is I'm going to put in the top and hit equal, and then do divided by, and then type in the bottom. So it does answer. 9210 divided by 400. Okay, so on the top, okay, I'll leave several places there, and then let's see, I guess so you'll know what the bottom number will be. I'll do it separate. So log of 1 plus 0.0949 divided by 12. On the bottom, get this one. And when we divide that out, let's see, 0.0872941 divided by 0.00342104. Get about 25.5. So you could, that's fine. I had people just give me that answer, and that's fine. Or you could say it would take 26 months because you would have to do 1 more month to get that half of a payment in. So either answer is okay there. Make sure that one comes out right. That one's one of the trickier ones in the calculator. Any math questions on punching that one? I'll get away from financial math for a little bit. got the 45-cent stamps and the 7-cent stamps. Again, just you can just do trial and error on these. Typically what I like to do is I like to take the total amount and divide it by the biggest stamp, so 45 cents would be 0.45, to figure out what the most of the big stamps would be. So 2.36 divided by 0.45 gives me 5.24 something. So I know the max of the 45-cent stamps is 5. So then we could try, okay, here's my 45 centers, here's my 7 centers. And so if I do 5 of these, that'll give me 225. And I'm trying to get to 236, so that leaves me at 11 cents. 236 minus 225 leaves me at 11 cents. And I don't have any way to get 11 cents out of 7-cent stamps. So then I'll go down one. Instead of 5 of the big ones, let's do 4. That'll give me $1.80. And if I do the $2.36 minus $1.80, that gives me 56 cents left over. And 56 cents we can get with 7-cent stamps. You can divide it, right? So right now I've got 0.56 on my calculator, and I can do divided by 0.07. It comes out evenly, and it comes out to 8. If you add those two together, we'll get $2.36. So we'll have 4 of these and 8 of these. I think most of you did well with that on test 1. 15. Got a little bit more set notation. This one says write the set using the roster method. That means we're just going to list them out. But we do want to do our brackets. And it says B such that B is between 13 and 23 and B is an odd number. And since we've got the or equal to bars on there, we're going to use 13 and 23. So we'll just list out the odd numbers between 13 and 23. So 13, 15, 17, 19, 21, 23. That's our roster method set. Whatever one I'll give you, you'll include the numbers. Okay, I won't try and trick you and give you one that doesn't have the equal bars or anything. Okay. 16, I'm just going to write this a little bit bigger so you can see it better. 16 says list a tick mark. A tick mark means complement. So to list out a complement in the roster method, we want everything that's not in A. So anything that's in B or anything that's just anything that's not in A. Okay? And it doesn't matter what order you put them in, so I'm going to do the ones that are floating outside first. And then I'll do the ones in B. But it doesn't matter what order you have them in. And we just want everything that's not in set A. That's A complement. I'll write that down here. On that one? Okay. 17, we got a unit rate problem. So what we're looking for is we're looking for the price per battery. Okay? So we're going to put the money on top and the number of batteries on bottom when we divide. Okay? So for the first one, it'll be 211.85 divided by 620 batteries. So since it's per battery, we're divided by the batteries. And so that one comes out to like 34 cents per battery. When we do the other one, we'll put the money on top again. So 869 divided by 24 batteries. That one's about 36 cents per battery. So A is cheaper. A little bit. Gotta make sure you get the right numbers on top and bottoms, the main thing there. So per means whatever comes after that's the one we're dividing by. We're dividing by battery. Hmm. 18, we got a sale price we want to figure out. So we got a microwave on sale for 35% off the original price of $269.99. What's the sale price? So a couple of ways you can do this one. The kind of standard is we need to figure out what 35% of our original price is. So we'll change that to a decimal, it'll be 0.35. Multiply that by our our original price. And when we round, that's $94.50. That's our discount. And then we take our original price minus the discount. We're getting our microwave for $175.49. That one makes sense? All right. 19, we got a little more geometry here. There's only, what do I got here? 21? 21 on here. So 19, got a triangle. We want to know how many square meters of fabric it would take to cover the surface. So one thing we can do is we can flip our triangle around. We want to, that'll help a little bit. And so we want the area of this thing, the area of a triangle, that would be on the formula sheet. 1/2 the base times the height. So if we turn it that way, we've got the height, that would be 6, but we don't have a base. If you turn it the other way, you just have the base and not the height. Okay? So the bottom line is we need to figure out that other side. So to figure out that other side, we got to do a little Pythagorean theorem. So here I'm going to call 6 my A, missing side B, and then the side across from the right angle C. So then we subtract 36 from both sides. And we don't want B squared, we want B. I kind of ran out of room here. We take the square root of both sides. The square root of 64 is 8. This side has to be. Then we can plug into our area formula. 1/2 times 8 is our base now, times our height, which is 6. That comes out to 24 square meters. So this is like step 1, and this is step 2. That combined Pythagorean theorem with the area. Um, 20. Usually if somebody missed this one on test 3, they got their numbers upside down or something. Says we got a frequency distribution of the number of hours spent on the computer per week for 55 students. What percentage of students use the computer between 22 and 27.4 hours per week? So that's that row. We had 6 students in that category, but we want it as a percentage. So that's 6 out of a total of 55 students. So to get it as a percentage, we do 6 divided by 55. Bless you. As a decimal, that's 1, 0, 9, 0, 9. And then either, whichever way is easier for you, okay, we either multiply that number by 100, or we move the decimal place 2 places to the right. This is the same thing. And it says round your answer to 1 decimal place, so here we would say 10.9%. One more and we're done. One more, and it's financial math, unfortunately. But okay. It says suppose your salary in 2012 is $70,000. If the annual inflation rate is 5%, and I put some help in there, it's compounded yearly. Okay, what salary do you need to make in 2020 in order for it to keep up with inflation? So this one we would use our compound interest formula. Okay. So our principal, our starting amount here is 70,000. Our interest rate here is 5%, so as a decimal, that's 0.05. And this one is compounded yearly since we're talking about yearly inflation, so n will be 1 in both spots. And then for t, we want to know what we need to make in 2020. We subtract the year we're starting in, we get 8. So then it's a calculator problem from there. 70,000 times 1 plus 0.05 over 1 to the 8th power. We would need to make $103,421 and that one. Think you can handle those? We got try not to make it too bad. I'm trying and help you out. So that's it. I'll give you your test 3 back. That's it for the review. So let me stop the video here.